Okay, this here is concept 55. The next one is law of cosines, and again, this should have been something covered last year in math 2 or geometry, but if it's not new, hopefully, again, similar to law of sines, it isn't too bad. The law of cosines can be used to find the side of and angle measures of given two. The law of cosines can be used to find side and angle measures given two sides and the included angle. That would be side, angle, side, or three sides, side, side, side. And these are the formulas for law of cosine. Now, they seem really difficult at first to be able to memorize, but you'll see that at least my trick to being able to not forget them is pretty hopefully one that sticks with you guys too. The first one would be given triangle ABC, a squared is equal to b squared plus c squared minus 2bc times cosine of a. The second one would be b squared is equal to a squared plus c squared minus 2ac times cosine of a. And then finally the third one is c squared is equal to a squared plus b squared minus 2ab times the cosine of c. There's a mistake here, guys, sorry, this is cosine of b, my bad, sorry, terrible impression, I know. Okay, so the way I remember it is when you're dealing with, let's say, finding like side A or A squared given B and C, what you're going to do is, so you're working with trying to find A. So you're going to have A squared, and then at the other part of the equation you have the other two sides. So A squared would be equal to B squared plus C squared minus, it's minus all throughout three of them, okay, so that doesn't change. 2 times BC, again, you're using the other 2 times the cosine of the angle you're finding opposite to the side. So A, and then BC, BC. Okay, so the one that you're finding, the formula consists of the other 2 with the angle of opposite of the one you're finding. Right, so here's b squared, so you're going to have cosine b, and then the formula consists of a and c here. C squared, cosine c, so then the formula consists of a squared plus b squared minus 2ab. Okay, that's the way I remember it. I mean, like I said, maybe just practice it or just look at it for a few, pause the video, whatever you need to do, and hopefully it's one that sticks. So first problem here says finding sides, find each missing measure, round all answers to the nearest 10th. So I have this guy here, right? We're gonna find him, this side. So x squared is equal to, then I would use the other two sides, right? So 9 squared plus 23 squared minus 2 from here times the two measures, 9, 23, okay, times the cosine of the angle that's given, 71. And just compute all of this, put it in your calculator. 9 squared plus 23 squared, you're gonna get that x squared is equal to 610 minus all this here is gonna give you 414 times the cosine of 71. You're gonna get that x squared is equal to 475.2148, and then take the square root of both sides, right? You're gonna get that x is equal to 21.8. No plus and minus, right? Because we can't have negative measures here, so or negative lengths. So that's it. That's your answer. Number 2. Same idea, finding this guy. So x squared is equal to, and then you could just take 15 squared plus 17 squared minus 2 times the two angles, 15, the two sides, sorry, 15 times 17 times cosine of 39 degrees. So I know, let's be consistent. So then put this, right, compute it all in your calculator. You're going to get x squared is equal to 514 minus 510 times cosine of 39, and then you're going to get x squared is equal to 117.6556, and then take the square root of both sides. You get that x is equal to 10.8. That's all there is to it. Next one, it's described to us. It says in triangle ABC, angle B is 106, AB is 10, and BC is 7. Find AC. So then draw it out. ABC, angle B is 106, AB is 10, BC is 7, and then it says find AC, this guy right here. So x squared is equal to 10 squared plus 7 squared minus 2 times 10 times 7 times cosine of 106. Compute this, you get x squared is equal to 149 minus 140 times cosine of 106, and then you're going to get x squared is equal to 187.5892, and then take the square root. You're going to get that x is equal to 13.7, and that's it for this one. The next one says find each missing measure, round all answers to the nearest 10. So this time it looks a little different, but not giving the angle inside. Okay, but it works the same way. Okay, you got the 3 side measures, so you're just gonna plug into the formula as you would, but you're just gonna find cosine of whatever angle measure. So you're just gonna take the inverse sign at the very end, and so that's really all there is to it. One thing I just want to pause and quickly say, you might be thinking like, wait a minute, what formula am I really plugging into if it's not really denoting what's A, what's B, what's C? In these 3 problems here that I just did, it didn't really matter which one we called A, B, and C, right? So as long as clearly we were solving for one of them, we called that one x squared. So because, right, it was labeled as x. But there are some problems, or you know, on the ACT or somewhere else, you might see them where they do label your triangle like they do here. Okay, and that's how you know, and that's why there's 3 different ones here, of knowing which ones you would use and which one you plug into. So anyway, moving back here. Okay, so I mean, right, you just take 8 squared. Actually, no, you don't just take 8 squared. You want to take the one that would be opposite to the angle you're finding, right? Because notice that, right, whichever side you're finding, that's the cosine of the angle that you're taking. So right here, this guy, cosine x, right, and just like it's labeled here, right, if I'm using the first one, for example, if I'm finding little a, I would take cosine of the opposite angle here. So here, 8 squared to x, so 8 squared is equal to 10 squared plus 11 squared minus 2 times 11 times 10 times the cosine of x. So you're going to get 64 is equal to 10 squared plus 11 squared. You're going to get 221 minus 220 times cosine of x, and then from here you're gonna get, let me see, you're gonna get some negative value. Yeah, because you subtract 221 from both sides, I think that's still gonna be fine. So we get negative 157 is equal to negative 220 times cosine of x, and then yeah, when you divide both sides, you're gonna get 0.714 is equal to cosine of x, and then here you're going to take the inverse sign So cosine inverse, right, of 0.714. That's going to give you the angle measure, and when you do that in your calculator, you're going to get that x is equal to 44.5 degrees. Okay, so more examples, but similar case. So here's the missing angle, so I'm going to use the side that's opposite to it as my starting point. Okay, so 16 squared is equal to 13 squared plus 5 squared minus 2 times 13 times 5 times the cosine of x. Whoops. So you would compute this, and then when you do that, you're going to get 16 squared, 256, 169 plus 25, you get 194, minus 130 times cosine of x, and then subtract that from both sides. You're going to get 62. That's equal to negative 130 times cosine of x, and then I divide both sides. I'm going to get some negative decimal, so negative 0.4769. That's equal to cosine of x. So then x is equal to cosine inverse of negative 0.4769, and then you're going to get in your calculator x is equal to 118.5 degrees. Okay, so it's an obtuse angle. Next one, in triangle LMN, LM is 25. Okay, let's draw it out first. LMN, LM is 25, MN is 20, LN is 24, and then it says find the measure of angle L right here. So I'm starting with this one, right, because it's opposite to the angle I need to find. So 20 squared is equal to 24 squared plus 25 squared minus 2 times 24 times 25 times cosine of x. So 20 squared, you're going to get 400 is equal to 24 squared plus 25 squared. You're going to get 1201 minus 1200 times cosine of x. Subtract from both sides. You're going to get negative 801 is equal to negative 1200 times cosine of x. And then when you divide both sides, you're going to get 0.6675 is equal to cosine of x. So then cosine of 0.6675, whoops, inverse cosine is equal to x. And then do that in your calculator, you're going to get x is equal to 48.1 degrees. So that's really all there is to it. You're going to have more practice on this, right, making sure you get this right. And I would say the main point of the practice here is familiarizing yourself with the formulas. Next thing, we have some application. Give side measures to the nearest tenth and angle measures to the nearest degree. First thing I always tell, especially with my Math 2 students, because we do a lot of word problems there with our concepts, is draw out what you're working with. So we're working with triangles, so just draw out your arbitrary triangle like that. Okay. Alright, let's see. It says Maple Street, Oak Drive, and West Ave intersect to form a triangular piece of land. The angle formed by Maple Street, so maybe we should we should just like label these so we know what we're looking at. We got Maple Street, we'll call this one Oak Drive, and then West Okay, and then it says the angle formed by Maple Street and Oak Drive is 79 degrees. So I have 79 degrees there. If the Maple Street section of the triangle is 390 feet, right there, and the Oak Drive section is 250 feet, so I have 250, that's a 5, 250 there. It says find the length of the West Ave section, so I need to find this guy here. We'll call that one X. So just becomes just like the other ones, right? X squared is equal to, and you got some big numbers here, 390 squared plus 250 squared minus 2 times 390 times 250 times the cosine of 79. So you have your calculator handy, okay? Once you put these here, you're gonna get let me see, 214 600 minus, that's 390 squared plus 250 squared, mind you, right here, okay, minus so all these guys here, you're gonna get 19,500 times the cosine of 79. X squared is equal to, input all this in your calculator, you're gonna get 177,392.2459. Take the square root of both sides, you're gonna get that X is equal to 421.2 feet, so 421.2 feet. Okay. That's it. Next one. Here I have, draw just a triangle, right? Arbitrary. It says Jack and Tom started at a tree and beginning running apart with an angle of 23 degrees between them. Okay, so I guess it's like you can consider the one of the corners here to just like be their starting point. So if they're starting here, they just start running in and running apart with an angle of 23 degrees between them. So if Jack runs 50 meters and Tom runs 38 meters, so let's say this guy, right, Tom goes running this way and the other guy runs that way, right, like that. It says find the distance between them. So right, if they stop here, they stop there, that would be the distance there. So X squared is equal to 38 squared plus 50 squared minus 2 times 38 times 50 times the cosine of 23. X squared is equal to 38 squared plus 50 squared. If you do this in your calculators, you're going to get 3944, and then all these guys, if you multiply them out, you're going to get 3800 times the cosine of 23, and then input all this in your calculator, you're going to get X squared is equal to 446.0816, and then take the square root, you're going to get X is equal to 21.1 meters. That's it. Last one here. It says two radar stations 2.5 miles apart are tracking an airplane. So let's just draw our triangle. It says two radar stations 2.5 miles apart are tracking an airplane. So right, you could just say, okay, here are my two radio stations. We'll call them, are they labeled? They are. It says the straight line distance between station A and the plane is the straight line distance between station A and, okay, so station A, station B, so let's call this A and B. And I apologize for not being more fluent with this one. So here are my two radar stations, A and B. They're 2.5 meters apart. Okay, they're tracking an airplane. The straight line distance between station A and the plane is 7 miles. So if this would be the plane, it would be 7 miles from station A. The straight line distance between station B and the plane is 9 miles. So that would be this guy here. In other words, you could say that the plane is here, right? We'll call that one P. And then it says, what is the angle of elevation from station B to the plane? So, let me see, the straight line distance. Yeah, you would say that this one here, that's the one we're looking for. So, we're using this side, and that's the cosine of the angle I'll be using. So 7 squared is equal to 9 squared plus 2.5 squared minus 2 times 9 times 2.5 times cosine of x. 49 is equal to 81 plus you're going to get 87.25 minus 45 times cosine of x. If you subtract 87.25 from both sides, you're going to get negative 38.25 is equal to negative 45 cosine of x. Divide these by negative 45, you're going to get 0.85 is equal to cosine of x. So then x is equal to the inverse cosine of 0.85, and if you do that, you're going to get that x is equal to 32 degrees. So this guy here is 32 degrees. That wraps up. Law of cosines. So hopefully, again, this one's not too bad. Just like law of sines, it's just plugging in and figuring it out. But of course, ask me for help if you had any trouble understanding any of the algebra done here.